Welcome back. We are continuing our tour through your joints. So we are going to have these 6 different types of synovial joint. For each one of these, you want to know its description, you want to know an example of that joint, and you want to know what types of movement are possible at that joint. So none of these are essay questions. It's simply be able to match the description of the joint with the joint type that's listed here. So we will start with plane joints. In a plane joint, you have 2 flat articular surfaces. This allows for gliding movements. The best examples of plane joints in your body are the joints in between your carpals, or your intracarpal joints, as well as your intertarsal joints. Next up is the hinge joint. In a hinge joint, I don't have the description written down. It is generally some sort of convex round groove that fits into some sort of concave round groove. This allows for uniaxial angular movement. The best examples of this in the body are your elbow, your knee, and the joints between your fingers, or your intraphalangeal joints. This does not include your first knuckle, which is a joint between a phalange and a metacarpal. Then you have pivot joints. In a pivot joint, there is some rounded end of a bone that fits into some sort of fibrous sleeve or ring. These joints only allow for rotation, and examples would be the radio-ulnar joint. So this is at your elbow, where do your radius and ulna meet at their proximal ends. And if you turn your hand over, like palm up to palm down, the proximal end of your radius simply rotates in that sleeve right there. Then you have a condyloid, or ellipsoidal joint. In this joint, both of the articular surfaces are oval. So you have a convex oval shape and a concave oval shape that fit together. This allows for biaxial angular movement. And the example of this in your body is the metacarpophalangeal joint. So this is the joint in between your fingers and your palm, so it's your first knuckle. And as we said, you can flex your fingers, open and close your hand, or you can wag a finger back and forth like you're shaming somebody and saying, that would be biaxial angular movement. Then you have a saddle joint, which there are not very many of in the body, perhaps only just one. In a saddle joint, both of the surfaces have both concave and convex areas. So if you look at just this bone here, like this part is convex and this part is concave. This allows for both biaxial angular movement and circumduction. The example of this is the joint between your thumb and your wrist, or your carpometacarpal joint. So this is the base of your thumb, not sort of where your thumb exits from your palm, but where the thumb portion of your palm attaches to your wrist. And that's what allows for you to have opposable thumbs and makes us humans tool users. And I think other animals can use tools and have opposable thumbs. But it's one of the things that us humans have. Then you have our last kind of joint, which is a ball and socket joint. This allows for all kinds of movement except for gliding. So you get multi-axial angular movement, rotation, and circumduction are all available to a ball and socket joint. There are 2 of these in the body, your shoulder, or the glenohumeral joint, or your hip. So that's all the synovial joints. Then it's just some odds and ends to sum up the end of the chapter, so it's really not that bad. So injuries, if you want to know what a sprain is when a ligament is either stretched or torn. If anybody's ever sprained anything, you also know that it becomes more likely that you'll sprain it again, because once you stretch a ligament, it doesn't necessarily return to its original shape. So once you stretch out a ligament, you've destabilized that joint because the cables holding it together have been stretched and are now kind of loose. I wouldn't worry about cartilage tears. I don't know how to ask questions about that. Here's an example of a cartilage tear right here, all of this rough looking stuff that's not smooth like that. That is a tear in the meniscus of somebody's knee, so that's a tear in the fibrocartilage. Let's see. Dislocations we're not going to worry about either. We're just going to skip that. And we are going to go right ahead to bursitis. And just know that bursitis is the inflammation of a bursa. This is sometimes called, if you've ever heard of somebody getting water on the knee, happens a lot with impact injuries, where somebody gets hit in the knee, like playing football, and then their knee swells up, and you go to the urgent care of the hospital, and they stick a needle in, and they drain all the swelling, and then tell you to put ice on it. Tendinitis is similar to bursitis, only it's inflammation of a tendon sheath, and instead of being an acute injury, like bursitis, this is all much more likely to be an overuse or repetitive stress injury. So tennis elbow would be an example of tendinitis. Then you have arthritis. We are going to go over 3 different forms of arthritis: osteoarthritis, rheumatoid arthritis, and gouty arthritis. What all of them have in common is that there is pain, stiffness, and some degree of swelling in the joint. So first up is osteoarthritis. What do we need to know for osteoarthritis? This part right here is the basic definition. Your cartilage, or your articular cartilage, is able to replace itself over your lifetime. In some people, and in most people, once they hit a certain age, the cartilage stops replacing itself, and then as you wear it down, it doesn't come back, and you lose the cartilage, and you end up with bone rubbing up against bone, and that's osteoarthritis. So it's common because many people get it. So here you have an example of a healthy knee, and this is a knee with arthritis. So here you can see there's this nice big joint cavity. That's actually where the cartilage is. It just doesn't show up in the x-ray. And over here you can see that the cartilage is gone, and you just have bone rubbing up against bone. One of the other things you can notice is how crisp and clear the lines are here. And then in this x-ray, especially over here, these lines look a little fuzzy, and you have a little lip right there. That's bone spurs. So what happens is when the cartilage is gone, the 2 bones rub against each other. That causes stress, and in response to the stress, the bone starts to grow. So you get these ruffled edges or bone spurs around the outside of the articular surface as the arthritis starts to continue, or starts to continue as your knees and joints deteriorate. Then you have rheumatoid arthritis. You'll notice I should say all of this stuff in gray is stuff that you don't need to know. I didn't have the heart to delete it, but you don't need to know it. So what you need to know about rheumatoid arthritis is that this is an autoimmune disease. It is a chronic inflammatory disease, tends to strike people younger than osteoarthritis, and there are treatments for it, but we're not going to worry about the treatments. Here's just an x-ray, what looks like a computerized color x-ray of somebody with rheumatoid arthritis, and you can see that there's so much swelling that the bones have actually become misaligned, like the pinky is completely out of alignment here, and you can just see how degenerated and sort of unclear, unrefined the ends of the bones are. So there's a lot of bone spurs and degeneration going on there. Then you have gouty arthritis, or gout. And this is what happens when you get the deposition of uric acid crystals in your joints. And one can imagine if you have crystals in your joints, that is going to affect how they work. It is going to cause pain and inflammation. And for reasons I do not understand, is most likely to affect the joint at the base of your big toe. That is it. Thank you for making it to the end of the second video. You are done with Chapter 9 on joints.